Okay, folks, we're back for part 2 of our exam review. So we've just completed questions 1 through 16. We're going to do, about a dozen more, I guess, before it's all wrapped up. So number 16 is a wavelength problem, and I give you frequency. Now there are 3 equations you folks need to remember for the exam. I won't give these to you. The first is lambda nu equals c, and then we have E equals h nu, and then E equals hc over lambda. Now, I'm going to give you the numerical value of c if you need it, and I'll give you the numerical value of h, Planck's constant. So here, I want to know the wavelength, and I give the frequency. So we're going to use this equation, and we're going to solve for wavelength, which would be c over the frequency. So let's find some room to work this right over here. The speed of light, we'll use 3.00 times 10 to the 8th meters per second. And let's see, we want to divide by the frequency, which is 8.22 times 10 to the 9th. And hertz, the unit we use is 1 over seconds, but since we're dividing by it, seconds pops up on top. So seconds divide out, and we're left with meters. So we'll pull out our calculators, clear this, and we're going to take 3 second e to the 8th, and we are going to divide it by 8.22 second e to the 9th. And we end up with 0.0365 meters. So it looks like letter B is our answer. Okay. Number 18, it's another wavelength problem. Probably should have mixed that up and given you a frequency problem, but nevertheless, it is what it is. So we're going to use the same equation, c divided by frequency. And so c is the speed of light, 3.00 times 10 to the 8th meters per second. Notice how I'm setting this up with my units. And I want to divide by the wavelength. Now, the radio station is 110 megahertz. And if you remember, mega means 10 to the 6th. So it's 110 times 10 to the 6th hertz. So we'll divide by 110 times 10 to the 6th, 1 over seconds. So we're going to have our answer in meters again. So let's go 3 second e to the 8th divided by 110 second e to the 6th. And we end up with, looks like about 2.73. And so letter D is our answer. Okay, so make sure you can do that type of math. Once again, a calculator certainly is nice. You're either going to be multiplying or dividing. Don't make this too hard. And like I said, on the multiple choice, 9 out of the 36 questions, you're going to be doing some math. So please come prepared for that. It might be a good idea to work through some of the examples we've done in your notes. Maybe cover up the answers with a piece of paper and work the problem off to the side. And then, after you've worked it, uncover the answer and see how you did. If you can do the ones in your notes, you can do the ones on the exam. Okay, let's see. It looks like when I printed this, the equations didn't come out, so I'll just give you the answer for this one. The relationship between energy and frequency. So that's going to be E is proportional to the frequency through Planck's constant. So E equals h nu. So the answer to that one was letter C. Okay? All right, quantum numbers. Yay, quantum numbers. So remember, for quantum numbers, n is the principal quantum number. It's the energy level of the electron. Its numerical value is any integer that's greater than or equal to 1. L is the sublevel, and its numerical value ranges from 0 to n minus 1. M is the magnetic quantum number, or the orbital or orientation of the sublevel, like some like to call it, and that ranges from negative to positive L. And S is the spin quantum number, that's either positive or negative 1/2. The way the L and S are written here, it looks like it's M sub L and M sub S, so this is the spin and this is the M, or magnetic quantum number here. So which one determines the subshell? That's also the sublevel. So the sublevel would be the L quantum number which is letter B. Which one would be the energy level? Yeah, if you said N, that would be correct. Which would be the orbital? Yep, that would be M. And which would be the spin? Yep, that would be the S quantum number. Good. Alrighty, on to the next page, number 21. So we can scoot this back up a little bit, don't we? All right. How many orbitals make up the 4D sublevel? Well, I don't care if that's 3D, 4D, 5D, or 17D. The important part here is D. The D sublevel has how many orbitals? Think, think, think. Let's see. The S sublevel has one orbital. Oh, you can't see where I'm writing here. The P has 3 orbitals, and the D has 5 orbitals. The F, of course, has 7 orbitals. And so those are orientations of the sublevels. The only two that you really need to know the shape of will be an S and a P. S is spherical, and P sort of kind of looks like a figure 8. So for a D, how many orbitals do we have? Well, that would be 5. By the way, D's numerical value is 2, so the orbitals range from -2 to +2. So you can see there are 5 in there. 5 orbitals for a D sublevel. Okay, now I want to know the value of L that's related here. Well, everybody knows that that's a P orbital, right? A figure 8. But what is P's numerical value? Let's see, the sublevels range from 0 to n-1. So an S's numerical value is 0, a P's numerical value is 1, a D's numerical value is 2, and the F's numerical value is 3. So this is a P, so the numerical value is 1, letter B. Okay, the configuration for nitrogen. So nitrogen, let's see, its atomic number is 7. So Z equals 7 for nitrogen. Remember, according to the Aufbau principle, we're going to start with the lowest energy first, which is 1s, and we can fit 2 in an s orbital. And now the first energy level is full. Then we're going to go to 2s, and like we said, we can fit 2 in that orbital, so we have 4 of my 7 electrons. The second energy level, of course, can also have a p sublevel, but we only need 3 there to add up to our 7. So 1s2, 2s2, 2p3, and that is letter C, it looks like. Now I could ask a question like this on the test. What's its dot picture? And what's its dot picture? Well, let's see, an orbital diagram might be helpful here for the valence electrons. So the second energy level is my highest energy level. The 2s has a pair in it. And the 2p, remember there are 3p orbitals. The 2p has 3 electrons in it. Remember, they go in one at a time until the orbital's half full, then they can start, sublevel, is half full, then they start pairing up. That's called Hund's rule. So in my dot diagram, I have the symbol for the element nitrogen. Those 2 electrons are paired up, so I illustrate them as being paired up. And then these 3 are all by themselves. So the other 3 sides have 1 dot in them. So that would be the dot picture for nitrogen. Be prepared to do dot pictures. Remember, what's the most or the highest number of dots we can have around an element? That's right, 4 pairs or 8. So keep that in mind. If I give you something like krypton on the exam, don't be putting 36 dots around it like I seem to see every single year. Okay, 24. You know what? There's an exception when we do electron configurations, and copper happens to be one of them. Let me show you what the configuration you might want to put for copper. Copper's right over here. And so its configuration is 1s2. Oh, let's zoom out a little bit so you can see this a bit better. Okay, so we got to go here to copper. So we have 1s2, 2s2, then 2p6, then 3s2, 3p6. Now normally we would say 4s2. Remember the D block is 1 behind the row number, so this is 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Now it turns out that 9 is painfully close to 10, obviously. In other words, it's very close to having a full D sublevel. And it turns out that atoms are more stable when their D sublevel is full. So in the case of copper and with silver, one of these s electrons is promoted to fill up that D sublevel. And when that happens, it becomes 4s1, 3d10. So yeah, don't worry about that for this exam. That's an exception to the rule. In fact, don't let it confuse you too much. I'm not going to give you any exceptions on your exam. Probably shouldn't have put that question on the test or on our practice test. Okay, number 25. Let's see, which of the following sets of quantum numbers is possible for a 3D electron? So let's think about that. 3D. That 3, kiddos, tells us the principal quantum number, the energy level, or the n number. So n equals 3 for this electron. So I can cross off letter B, and I can cross off letter E, because n equals 2 and 4 in those. What's D's numerical value? Do you remember? Let's see, S's numerical value is 0, P's numerical value is 1, D's numerical value is 2. So I'm looking for an L equal to 2. So the remaining, L here equals 3, that's not right. L here equals 1, that's not right. Oh, L equals 2, that's my monster. Okay, remember M can range from negative to positive L, and S can be either positive or negative 1/2. In this case, the halves are left off here, but I can write those in quickly. So my answer is going to be letter D for that. Okay? What if I said it was a 3p? What if I said 3p? Well, the energy level is the third, and what's P's numerical value? 1. Yeah, so I'd look for n equals 3, L equals 1, which would have been that monster right there, letter C. What if I said it was a 4p? A 4p. Well, n would equal 4, fourth energy level, and P's numerical value is 1. So I look for 4 and 1, and there it is right here on letter E. Okay? Just a bit more review for you. All right. And the last one in our review, which of the following distributions of electrons is correct for 3 electrons in a p subshell? Hopefully you folks remember Hund's rule. And so that basically says electrons prefer to be by themselves. They don't like to pair up unless they have to. Remember, if you have 2 electrons in the same orbital, they're going to repel each other. So it takes extra energy to keep them together. So if I have 3 electrons in a p sublevel, remember p has 3 orbitals, -1, 0, and +1. I'm going to put 1 electron here. The second one will not pair up. It won't do that. It'll go into an orbital by itself, and the third one will take an orbital by itself. So if we have 3 electrons, they will be unpaired. All 3, of course. And so it looked like letter A. Just for the record, if you guys put letter C and had one of those having an opposing spin, so long as it's in an orbital by itself, I probably wouldn't care too much about that. But A is our best answer. Okay, electrons prefer to be in orbitals by themselves. Alrighty, kiddos, let me just do one more thing for you that you might see pop up on the exam. What if I asked you for the dot picture and electron configuration for bromine? So bromine will have 35 electrons. Okay, I guess we can zoom back in here a bit. Bromine will have 35 electrons. That's its atomic number. And where are we going to start? Well, we're going to start with the first energy level, 1s2. Right, going across and back out. So 1s2, then 2s2, 2p6. So let's get ourselves caught up. 2s2, 2p6. Then we hop down to 3s2, 3p6. Then remember what happens after 3p6. We go to 4s2. We don't go to 3d yet. We go to 4s2. Then we go to 3d10. And finally 4p, 1, 2, 3, 4, 5. 4p5. So that's my electron configuration. The noble gas configuration would be the noble gas before bromine, which is argon. So I put argon in brackets. And then I just finish it up after argon, which would be 4s2, 3d10, 4p5. 4s2, 3d10, 4p5. Okay, now what about its dot picture? How many dots will be in its dot picture? Well, some students will say 5, and you're wrong. Remember, the dots we include in our dot picture are our valence electrons, those that are in the highest energy level. P is my highest sublevel. My highest energy level is the 4th. So there are 2 in the 4s and 5 in the 4p, so there are 7 dots for bromine. So let's see if they're paired or not. So we're going to do a little orbital diagram here. My 4s has a pair in it, and my p, remember there are 3p orbitals. There are 5 electrons, 1, 2, 3, 4, 5. So we're going to have 1, 2, 3 pairs, and 1 all by itself. So that's your dot picture for bromine. Okay? All right, kiddos. You can do this. Study, study, study. Go over your notes. Practice your problems. Cover up the answers with a piece of paper. Practice them off to the side and then uncover. Most of your problems are not going to be math. The math is multiplying or dividing. You guys can handle that. A lot of conceptual things that'll be on the exam. Probably 2/3 of the exam will be non-mathematical. So prepare yourselves well. Study hard. Come see me if you have any questions. Watch these videos over again. Watch the other videos in the series as review. So good luck to you, and we'll see you in class. Bye-bye.